And then we'll move directly into the upper limb. So upper limb bones are the framework for the arm, the forearm, and the hand. Muscle attachments, basically they work like a lever, and we talked about that before. Humerus is the long arm bone. So the humerus would be the arm that articulates with your scapula. It articulates at its head, so the head of a bone is usually the rounded part. So this would be the head of the humerus. It articulates with the radius at the capitulum, which is down here, and that's going to be on this side, and the ulna, the trochlear or the trochlea side of your humerus. Here, these I probably won't ask so much other than the coronoid fossa and the olecranon fossa, and I'll point those out on the diagram. So if I'm looking at the picture, if I'm looking at a diagram that you're going to label, the head is the top, greater tubercle, lesser tubercle, greater tubercles will always be on the top, lesser will be on the bottom, no matter what kind of bone we're discussing. There is a deltoid tuberosity. That's going to be where your deltoid will actually attach to. But if I'm looking here, there's condyles and epicondyles on some of your long bones. Epicondyle is going to be on top. So my humerus is going to have a lateral, so that's going to be the outside. That means my arm is facing this way. This is the lateral, this is the medial. If my arm is this way, this is the medial, and this is the lateral. On that, olecranon fossa is where your olecranon process is going to fit. That's your elbow, and that comes from your ulna. Coronoid, notice it's not coracoid. Coronoid fossa is where the coronoid process is going to fit. So radius, and this is the way I've remembered, the way you remember it forever. The radius is thumb side. So the radius bone is going to be on the thumb side of your arm. No matter how I turn my arm, my radius bone will rotate with my thumb. So located on the thumb side, it goes from your elbow to your wrist. Disc-like head pivots with the capitulum of the humerus. So this one doesn't have, here we go. If I look at this, the head of your radius is a little bit flatter at the top, but here it's going to move and pivot where it hooks with the capitulum. Other features, radial tuberosity and the styloid process, and I'll point those out on the diagram and also on your body. Ulna is the longer of the two. Ulna will be pinky side. It's going to have a trochlear notch, and that's where it articulates with the trochlea of the humerus. I do want you to know, number one is probably the most important statement on this slide. The olecranon process is your elbow. So when you hit your funny bone and it hurts, that's actually a nerve on your olecranon process, which is part of your ulna. The coronoid process, both of these are going to fit into your humerus. And then your ulna also has a styloid process. So both your radius and your ulna will have a styloid process. Distal end articulates with the wrist. This is a typo. The ulna is on the pinky side, not the thumb side. So radius, thumb, pinky, ulna. That's the easiest way to remember them. So, if I'm looking at both of them together, I'm going to start with the styloid processes. So if I'm looking at my wrist, I have a little bump that sticks out on my pinky side. That would be the styloid process of my ulna. On the other side, I don't notice it as much. It comes down a little bit further. But basically, where your wrist bones end, or what you classify as your wrist, styloid process of the ulna, styloid process of the radius. So each one of them has a styloid process. When I'm looking at my elbow, olecranon process is this hook that actually comes around. So if I'm actually looking at my arm, so here's my humerus, here's my elbow right here. So this is the olecranon process, and that's the ulna, and you can see how that moves. So the olecranon process fits into the olecranon fossa. Fossa is like the indentation. If I turn it around on the other side, I have the coronoid process, and that slides up and fits into the coronoid fossa. So the fossas are on the humerus, and the processes are on the ulna. And that's probably what you need to know there. The hand itself. The hand is made up of wrist, palm, and fingers. The wrist is 8 little carpal bones, so your wrist is actually these tiny short bones. They each have individual names. I am not requiring you to memorize those. I will not have you memorize the carpals. The framework of the hand, so if I put my hand here, notice these long bones take up my hand part. So the hand bones are called metacarpals. So that's the first long bones that are right here. And then the fingers themselves are composed of 3 actual phalanges. In each finger, other than the thumb only has 2. So if you take a look at your fingers right now, when I bend my thumb, I can see 2 parts to it. Every other finger, I see 1, 2, 3. So all of your fingers have 3 parts other than your thumb. So if I look at those, here's your individual carpal bones. And like I said, I don't have you memorize those. College anatomy class, most definitely you'll probably be required to memorize those. When I look at my digits, they're numbered. So the thumb is going to be 1, 2, 3, 4, 5. So 1 starts with the thumb and moves outward. These are my metacarpals that make up the hand part, basically, of my hand. It makes up the hand, or the palm part, I guess is what I should say. When you look at your phalanges, or your fingers, so here's the end of my hand. I have a proximal phalanx, a middle phalanx, and a distal phalanx. Distal being the furthest away, proximal being the closest to your metacarpals, and then middle is going to be in the middle. Your thumb will only have a proximal and proximal and a distal. It does not have a middle phalanx. There's only 2 parts to it. And that's where we'll stop.